Now we want to talk about solving inequalities. So it works a lot like solving equations. There's just one little difference that we're going to talk about. So the idea is that we're going to get something, some variable x, to be greater than or equal to or less than or equal to, and then you're going to have some number over here. Okay? So some inequality symbol. So there's statements like equations are statements. They could be true or they could be false, but we're looking to solve them so that it makes a true statement. And we get it down to a statement such as x is greater than 5 or x is less than or equal to -3 or something like that. Those were statements that we were using in the last video where we were graphing them. Okay, so when you have an inequality, say you have A is less than B, you can add the same number to both sides, just like you do with equations. Or say you have A is greater than B, could be less than. You can say, you can subtract the same thing from both sides. No problem, just like we do with equations, and we'll give you some examples, okay? And they could be different inequality symbols, but whatever the inequality symbol is, you can add to both sides, you can subtract from both sides. Okay, so multiplication and division, there's a little difference. So say you have A is less than B. Then you can multiply both sides by a number as long as C is positive. You can do that, okay? I should say, yeah. Okay, so you can do that. And let me give you an example. Let's say you have 5 is less than 10. True, right? You could multiply both sides by 2. So you could say, times 2 times 2, and you'd get 10 is less than 20, right? So that's not a problem. To multiply both sides by a positive number, you can do that with an inequality. Same with division. Now, division is just the same as multiplying by the reciprocal, so that's going to follow the same property. But if you have A is less than B, and you want to multiply by a number that's less than 0, so a negative number, then it becomes AC and is greater than BC, and you switch the inequality. So that's the property. Now let me show you why that happens. So if you had 5 is less than 10, true, right? But if I multiply by a -2, so let's say I put in a -2 here to multiply by, see, then I'm going to get -10 on the left, and I'm going to get a -20 on the right. But -10 isn't less than -20. It's greater than. So that's why the inequality has to switch its direction. It's like the possession arrow in basketball. It's got to go the other way. All right. So that's how it works. That's the rule. And it could work for any of the inequality signs. But the thing is, when you multiply or divide by a negative number, so when you multiply or divide by a negative number, the inequality changes direction. So if it's a less than, it becomes a greater than. If it was a greater than, it becomes a less than. Okay, so you kind of have to remember that. It's just the big thing on inequalities, and nobody's going to come and tell you, hey, you need to switch your sign. You have to remember, oh, I multiplied by a negative. If you multiply by a positive, that's fine. But okay, so here we go with some examples. Solve each inequality, graph the solution on the number line, and write the solution in interval notation. So I'm going to give myself just, okay. So our first one, P minus 3/4 is greater than or equal to 1/6. So what we want to do is we want to add the 3/4 to both sides. Sometimes the books will write it like this. I like to do it in a different color. I didn't this time, but I'm adding that 3/4 to both sides. So on the left, I just get P. That's fine. Is greater than or equal to. So the sign's going to stay the same. All I'm doing is adding to both sides. Now on these cancel out. On the right, I'll have to get common denominators, which will be 12. So it's going to be 2/12 plus 9/12. And so that's going to be P is greater than or equal to 11/12. That's the statement. Now they want us to graph it. I'll graph it over here. Here's 0. Here's 1. So 11/12 is going to be, just to the left there. 11/12. Maybe I'll write 11/12 there. And I want P to be greater than or equal to. The equal to means a square bracket, and then the greater than symbol. And that's what the graph looks like. Now the interval notation, you can kind of follow it from the graph. It's going square bracket, 11/12, comma, to infinity and beyond. Anyway, and that's what the interval notation looks like. Okay, so that one's done. Now we'll go to the next one. This one's a little bit friendlier. You've got 9C is greater than 72. So you want to get rid of the 9. You want C by itself. Divide by 9. Divide by 9. C, I did not divide by a negative number. So it's going to stay a greater than symbol. C is greater than 8. So here comes the graph. 0, 1, 2, 3, 4, 5, 6, 7, 8. And we want C to be greater than 8. I always like to stop and think about what I'm doing. Don't be hasty. It's going to be a parenthesis, and it's going to be greater than. So the graph looks like that. And then the interval notation, parenthesis, 8 to infinity, parenthesis. Remember, infinity and negative infinity always get a parenthesis. Okay, so we have one more problem here on C. I'm going to recopy it to give myself a little room. 24 is less than or equal to 3/8 m. So you might be saying, well, how do I get rid of that 3/8? You're going to multiply by the reciprocal, which is going to be 8/3. So when you have a fraction, it's easier to just use the reciprocal rather than think, oh, I got to divide by 3/8. It's the same thing. We've worked with complex fractions, so you can handle that, but it's probably easier just to write times the reciprocal. Okay, so on the right, the 8s are canceling, the 3s are canceling, and I'm going to get m. Oh, I know why this problem's here. Okay, so the variable's on the right-hand side. So I was like, this one's going to be fun. I can put this over 1 if I want. 3 goes into 24 8 times, so I'm going to get 64. Now, here's the thing. We have 64 is less than or equal to m. That is the statement. But sometimes it's a little confusing to think about it this way because m is on the right-hand side. So if you've kind of gotten in the habit of having it on the left-hand side, the variable on the left-hand side, you might want to rewrite it. And here's how that happens. I kind of call it the matching or the marching band thing. It wraps around like the marching band's turning the corner. And I get, instead of writing 64 is less than or equal to m, I can write m is greater than or equal to 64. So that's the same thing. It's like saying I am, shorter than my husband, or I can say my husband is taller than I am. And so that's the type of statement we're doing here. So we're changing it to kind of wrap it around so that our variable will be on the left and make a statement m is greater than or equal to 64. This makes it a little bit easier to graph and write the interval notation. So 64 is a big number, so maybe we want to count by tens or something. 10, 20, 30, 40, make a bigger number one. 10, 20, 10, 20, 30, 40, 50, 60, 70. Okay, so 64 maybe is going to be, and maybe I want to put some labels down here to note how I'm my scale, and maybe 64 is right there. Okay, it's not a great graph, but anyway, I don't want to make 64 little marks. I need a very big piece of paper. Okay, so it's greater than or equal to, so it's going to go like this. And it's going to be all the numbers that way. Now, how does that look in interval notation? Well, it follows the graph. So it's square bracket 64, comma, to infinity. And it would look like that. So that one was a little tricky because you have to do that wraparound thing. I think that's the easiest way to look at it. Okay. So now we have another example. Solve each inequality, graph the solution, write it in interval notation. Okay, so the first one, negative 8q is less than 32. We want to divide by negative 8. Okay, so I'm going to have q. All right, I divided by a negative. That means the inequality has to change direction. So instead of being a less than, it's going to be a greater than. It doesn't, switching that symbol is not going to affect my answer. I'm still going to get 32 divided by negative 8, which is negative 4. Okay, but it's the act of dividing by a negative, that's what flips the inequality. I mean, our answer could still be positive on the right, but that's not the case here. But anyway, hopefully that makes some sense. 0, 1, 2, 3, 4. Here's negative 4. Now I want the numbers greater than negative 4. Q is greater than negative 4, so it's going to be parenthesis and off to negative 4. It's a parenthesis because it doesn't have the equal to part this time. So, and then writing it in interval notation, it's going to be parenthesis, negative 4 to infinity, and that's what it would look like. All right, so we have one more. We have k over negative 12 is less than or equal to 15. So what we want to do is we want to multiply by negative 12 on both sides. Multiply by negative 12. So those will cancel out. Then I'm going to have k, but I multiplied by a negative number, so I've got to switch it the other way, greater than or equal to. And then I got to figure out what 15 times negative 12 is. It's going to be a big number, right? So 15 times 12, negative 180. Well, it's really a small number, I guess I should say. Okay, so k is greater than or equal to negative 180. Okay, so I have to graph this. Oh my goodness. So 0, I don't even want to count by 10s. I count by 20s. Count by 30s. All right. We'll be creative. 30, 60, 90. No, I'm making them too big. 120 and 60, 180. And these are all negative. That should work, right? So negative 30, negative 60, I can fill these all in. Negative 120, negative 150. Okay. Anyway, I got to the negative 180. I want k to be greater than or equal to, so bracket, and this way. And so then my interval notation is going to be bracket, negative 180, comma, infinity. And there it is.